Hello, scientist. Sometimes we're trying to figure out how much force is needed to do work, or how much distance can I cover if I put in this much effort. And one way we can do that is by using a work equals force times distance formula. And so what I would like to do is through 4 problems is show you different variations of the work formula to help you with your independent work. So let's look at number 1. When I am reading the word problems, I like to annotate for the things that it's asking me for. I might do this by underlining. I can circle important words like I'm solving for work, so that might be circled. Or I might color code it as you see right here on the screen. So as I'm looking at the question, Amy uses 20 newtons of force to push a lawnmower 10 meters. And how much work does she do? Okay, so I could tell that I need to solve for work because the question is asking me how much work. And then I also know that it's work because the only information I have is for force and for meters. Now, if this did not tell me force or meters, how would I know that they are force and meters? One way I can know that is by looking at the units. I know that force is represented by newtons and meters represents distance. So here we go. My first step is to write down the formula I am using. This way I can see how my work plays out, and if I make a mistake, it's easier to go back and see how I made that mistake. Now I'm going to put in 20 newtons for force and 10 meters for distance. I just pull it straight from the formula. And once again, I want to show my work because if I do make a mistake, it's easier to go back and see where that mistake was made and then learn and grow from that. 20 times 10 is 200, and since I'm solving for work, my unit will be in joules. Pause this video and try to solve number 2 before proceeding. All right, scientists, let's look at number 2. Once again, I do want to annotate and take a look at what is this question asking me to do. And number 2 is asking the same question as number 1, is asking to solve for work. So how much work is being done? So that's work equals force multiplied by distance. And now I'm just going to pull that information from the problem to get 33 newtons multiply by 13 meters, and that gives us 429 joules. Now for the next problem, number 3, I notice that the question is asking me to solve for a different part of the formula, which is distance. I could tell that because of my annotations, and I'm looking at the question. It says, how far did she lift the grocery bags? On a side note, one thing you definitely want to make sure you do is before you start solving the problems is make sure that the problem is work. Remember, if you carry something or if it's an example such as a moving sidewalk, it is not work. Here we go. Since I am solving for distance, my formula changes. I am now distance equals work divided by force. And I can always use an engineer's triangle to help me remember all these formulas. By just memorizing the triangle, that's easier than having to remember all 3 different formulas. Okay. And now I want to take joules and then divide it by force. And once again, I am showing my work so that if I do make a mistake, it is easier to learn from my mistake. So 50 divided by 25 is 2 meters. Now let's look at number 4. 4 is asking for yet a different response. Take a look at the problem now and tell me, what are you answering for? If you said we are answering for force, then you are correct, and we know this because it tells us how much force did the player use. Also, when I look at the information given to us, we have joules and we have meters. That tells us that we have work and we have distance, but we do not have force. So I need to plug in force equals work divided by distance. And I can pull this from the formula to say force equals work divided by distance. Now I'm just using the information that I annotated for previously, and I'm plugging that into the formula, and I'm going to take 1,234 joules divided by 100 meters to get a force of 12.34 newtons. Scientists, I hope you found this helpful and informative, and now feel free to review back to this video and continue on your journey to learning about work, force, distance, and simple machines with motion. Bye guys!